All right, we're working with this day length function, and so this function models the length of day throughout the year, and it's not exactly accurate, but it's pretty darn close. Now, days change their length at different rates throughout the year. So, for example, in the fall, during the equinox, the days shorten really quickly, like they get 2 or 3 minutes per day shorter every day. On the other hand, in what's known as the solstice, the days remain at a fairly constant length. They change, but not very much. So this trigonometric function models that. Now, what's really ugly about this thing, and I think it's sort of freaking everybody out, it's just all these numbers and these pi's and fractions and the subtractions and all that kind of stuff. But really, this is the same thing. We have a function inside of another function. Okay, so if I took a look at this, here I have 171 sine of something, okay, plus 750. So this is my outside function. And I can just take the derivative of this fairly easily. So the derivative of sine is cosine, and so the constant multiple rule says this is going to be 171 cosine of all the junk that's in the middle. And then this is a constant at the end, and it's just going to turn to nothing. Now, the chain rule says I have to multiply by the derivative of the inside. So that's the outside derivative. Now I have to take the derivative of this. 2 times pi over 365 times n minus 80. This minus 80 is a constant, and so I know it doesn't affect the derivative. So I'm left with this 2 pi over 365 times n. And when I take the derivative of the inside function, because n is just a first term polynomial, it's going to drop away. And so I'm going to multiply the outside function derivative by just this number. And then at the end, this particular problem says, how fast is it changing on day number 185? So when I get my derivative all done, I'm just going to plunk in a 185 for n.